Under contract to the United States Air Force, this special-purpose high-altitude drone has been developed jointly by Teledyne Ryan Aeronautical, builders of the jet-powered drone, and Melpar, manufacturer of the communications intelligence sensors. This drone is a version of the Model 147T. With the application of the drone to this mission, only the listening ears of the SIGINT operators have been sent aloft, while the men themselves are safely and comfortably emplaced in friendly territory. Designated Combat Dawn, this special-purpose system has proven the concept of an unmanned aircraft equipped with a real-time intelligence data collection system to accomplish the signal intelligence mission. Teledyne Ryan has prepared this film as a review of the flight test program and oversees operational evaluation of the prototype system. Improvements are discussed. The TF Increased Endurance Drone, a near-term follow-on objective, and the TL High Altitude Long Endurance Drone, a long-term follow-on objective of the Combat Dawn program. When compared to present communications intelligence systems, Combat Dawn achieves higher altitudes and thus greater ranges for signal reception. Both the pilotless aircraft and the SIGINT sensors are controlled remotely from a distant ground site. Enemy communications intelligence data is not stored aboard the drone, but is transmitted in real time by downlink through a steerable antenna to a ground control van, then to central control stations called High Altitude Reconnaissance Comment, or HARC vans, where the data is monitored, recorded, and prepared for analysis. Remote control radio tuning commands are transmitted to the drone by UHF uplink. Through flight test and an operational evaluation at a Strategic Air Command operating location, the TE has proven this dramatic new concept. The TE, TF, and TL drones are modifications of the Model 147T, 84 of which will have been produced under Air Force contract. The initial flight test drone was delivered in 5.5 months, and 4 prototype systems were in place in the OL 2 months later. Major changes between the T and Combat Dawn drones included removal of Doppler radar and camera equipment and modification of the nose module to accommodate the Melpar High Altitude Reconnaissance Comment Platform, or HARC, and other electronic equipment and antennas especially designed for the Combat Dawn mission. By November 1969, the first Combat Dawn prototype was delivered on program schedule and shipped to the Pacific Missile Range, Point Mugu. Represented on the flight test team were Air Force, Teledyne Ryan, Melpar, and other associated contractors. Included in the successful 8-week flight test program were 2 captive flights and 9 free flights. 3 of the 4 prototype Combat Dawn drones were utilized. The 9th and final free flight was considered by the operator to be an outstanding graduation mission. The flight test successfully demonstrated compatibility of all Combat Dawn subsystems. Interface was accomplished between the drone, the DC-130 launch aircraft, the drone ground control and tracking unit, the TPW-2, and the ground control central vans. The new lateral control system, which was modified for the Combat Dawn mission, functioned as designed.
-5, 4, 3, 2, 1. Release. Bird is clear, bird is clear.
Average actual maximum altitude during the flight test series was in excess of 72,000 feet. Throughout flight test, the TE demonstrated excellent heading hold and navigational capability. In its final configuration, the downlink system performed excellently. The capability for dual back-to-back missions was also demonstrated. While the first drone was airborne, the second was checked out and successfully launched before the first drone had completed its flight. Both drones were in the air at the same time. Valuable experience was gained in this dual flight demonstration. Next stop, the OL. The Combat Dawn system was crated and flown by C-141 to Air Force Operating Location 16. First transport departed Point Mugu on February 2nd. All major units were in place at the OL by February 11th, and 4 days later, the first mission was flown. Like the basic 147T, the 147TE proved to be a highly stable platform in flight. Sensor performance was rated as excellent. Some problem areas identified during the OL evaluation can be readily fixed to provide an overall Combat Dawn system that will be highly reliable, versatile, and effective in its communications intelligence gathering role. 22 sorties were successfully flown. Total mission time was 61.5 hours, with 56.3 hours of actual Combat Dawn systems operation. One problem area concerned the loss of downlink data. The problem was solved by a change in the type of rigid coax cable and a rerouting of the cable around an engine hotspot. 7 propulsion problems were encountered. One of these was solved by better definition of engine start and abort procedures. Utilization of newer model fuel controls, replacement of the main fuel boost pump and other components with higher MTBF items is recommended to yield higher reliability. Recommended fixes will improve reliability and increase the mean time between failures of the propulsion system to a degree acceptable to the mission requirement. Further improvements in engine operation are being implemented with the GFE engine supplier to achieve even longer engine life. MCGS and flight control problems were identified and easily corrected. The combined industry and Air Force evaluation team were impressed also with the effective attrition rate of the TE drones used in the deployment test. 1 drone per 10 1/2 sorties. With the recommended improvements, this rate is expected to be 1 drone per 20 or 30 sorties. The special orbit mode system, installed especially for the TE mission, proved highly satisfactory at the OL. Stable flight attitudes were held throughout continuous orbits. Coordination procedures developed between air controllers in the DC-130 and ground controllers in the TPW-2 were adequate. Proposed system improvements will further enhance team effectiveness. Restrictions on the operational route, however, did not permit complete evaluation of the control system's maximum range capability, 300 nautical miles. Mid-air retrieval results were outstanding, according to evaluation reports. As a follow-on to this prototype program, Teledyne Ryan has suggested several design improvements for an operational Combat Dawn system, which shall be called the 147TF Increased Endurance Configuration. These improvements are required to effect a more reliable vehicle and to improve the special equipment capability to better meet the user's requirements. Objectives of the TF shall be to increase drone endurance and to increase HARC frequency coverage. The TF shall be compatible with existing support systems, including the TPW-2 and the improved HARC. Primary external difference between the TE and the TF is the addition of fuel pods on the wings. A series of flights at Point Mugu demonstrated that the TF wing, which carries 32 gallons more of fuel internally than the standard T wing, can also carry 2 115-gallon pylon-mounted fuel pods. This added 262 gallons of fuel increases the effective endurance of the basic TE drone from a flight time of 4 hours, 51 minutes to in excess of 8 hours. In addition to increased endurance, other improvements have been proposed for the operational TF system. Incorporation of a mission control center is considered essential to the realization of the potential of other improvements to the Combat Dawn system. The MCC would relieve congestion in the TPW-2 by combining its remote command control functions in a new console located inside the Hart van and provide capability to incorporate the additional improvement features. The TF offers these new capabilities: extended glide range, complete backup of drone command functions through the uplink system, radio-commanded self-destruct of the encrypting device, emergency command through the uplink to the autopilot in the event of engine rundown. Also, the emergency return to base heading will be made more accurate through the use of the downlink heading, which will itself be modified to slew automatically to the Hart van. Greater protection against interception or jamming of the MCGS signal, and an increase in antenna gain from 5 dB to 18 dB will be achieved by diplexing the signal into the downlink horn antenna. In addition, an improved HARC collection system is provided that will monitor more and different frequencies through interchangeability of receiver modules. This will expand uplink control from 4 to 44 channels. Encryption of the uplink commands will provide more system security. Downlink data is already encrypted. Modifications to the TPW-2 ground control system will increase effective range and angle track from 250 to 400 nautical miles. Teledyne Ryan is looking further to the future with the Model 147 TL, a version that will utilize the increased lifting and fuel carrying capabilities of a 180 square foot wing. Use of this wing, which will permit addition of 2,500 pounds of fuel, will enable 12-hour flight endurance, 11 hours above altitudes of 60,000 feet. Incorporating the improved HARC collection system, frequency coverage will be increased along with area coverage. With the TL, it will be possible to launch the Combat Dawn drone at a point well beyond the horizon, as seen from the HARC ground station. Launched at an altitude of 15,000 feet, the TL can fly to mission altitudes in excess of 75,000 feet. Such a mission profile will allow data collection from distant target areas more than 600 miles from the HARC ground complex. As frequency coverage requirements increase, additional payload volume can be obtained by stretching the TL fuselage a total of 53 inches. The nose will be extended 18 inches and the fuselage extended 35 inches for a volume increase of 10 cubic feet. Combat Dawn, an application of the unique high-altitude flight capabilities of the Teledyne Ryan Model 147 pilotless aircraft, combined with the advanced communication sensor capabilities of Melpar and the computer control expertise of UNIVAC. Combat Dawn, the optimal, low-risk, politically acceptable means of gathering vital intelligence from those nations that constitute a threat to the national security of the United States.